In this video, we're going to look at how we can solve equations using a method called inspection. Before we start, let's recap what an equation is and why we solve them. An equation is a mathematical sentence with two sides that are equal to each other. We solve equations to find the number or numbers that make the sentence true. So let's have a look at what it means to solve equations by inspection. If you were given this, all it is saying is something plus 3 equals 5. What's the missing number? 2. So that means x equals 2. That's all there is for solving equations by inspection. It just means to look at the question and try and work out what the missing number is. How can we make the left-hand side equal the right-hand side? So what about this question? What's the missing number? This is a little bit of a trick question. 15 plus what gives 5? We actually need to subtract 10. So y equals -10. So now this one is actually the same as saying 4 times a. So what's the missing number? Did you think 3?
We need to understand that an equation is like a balance scale. You've seen a balance scale, right? If there's the same amount of weight on each side of the scale, then the two sides are in balance. But if we add some weight to just one side, then the scale will tip. The two sides are no longer in balance. An equation is like that. Whatever is on one side of the equal sign must have exactly the same value as whatever's on the other side. Otherwise, the equation would not be true. Of course, that doesn't mean that the two sides have to look the same. For example, in the equation 1 plus 1 equals 2, 1 plus 1 doesn't look like the number 2, but we know that 1 plus 1 has the same value as 2. So 1 plus 1 equals 2 is in balance. It's a true equation. The reason we need to know that equations must be balanced is because when we start rearranging them, if we're not careful, we might do something that would change one side more than the other. That would make the equation get out of balance and it wouldn't be true anymore. And if that happens, we won't get the right answer when we solve it. Oops. That sounds pretty bad, huh? So how do we avoid that? How do we avoid getting an equation out of balance? The key is that whenever we make a change to an equation, we have to make the exact same change on both sides. That's so important, I'll say it again. Whenever we do something to an equation, we have to do the same thing to both sides. For example, if we want to add something to one side of an equation, we have to add that same thing to the other side. And if we want to subtract something from one side of an equation, then we have to subtract that same thing from the other side. And that's the same for multiplication and division. If we want to multiply one side of an equation by a number, then we need to multiply the other side by that same number. Or if we want to divide one side of an equation by a number, then we have to divide the other side by that number also. As long as you always do the same thing to both sides of an equation, it will stay in balance and your equation will still be true. All right, like I said, in this video, we're just going to focus on equations involving addition and subtraction. And here's our first example. X plus 7 equals 15. To solve for the unknown value x, we need to rearrange the equation so that the x is all by itself on one side of the equal sign. But what can we do to get x all by itself? Well, right now, x is not by itself because 7 is being added to it. Is there a way for us to get rid of that 7? Yes. Since 7 is being added to the x, we can undo that by subtracting 7 from that side of the equation. Subtracting 7 would leave x all by itself because x plus 7 minus 7 is just x. The plus 7 and the minus 7 cancel each other out. Okay, great. So we just subtract 7 from this side of the equation and x is all by itself. Equation solved, right? Wrong. If we just subtract 7 from one side of the equation and not the other side, then our equation won't be in balance anymore. To keep our equation in balance, we also need to subtract 7 from the other side of the equation. But on that side, we just have the number 15. So we need to subtract 7 from that 15. And since 15 minus 7 equals 8, that side of the equation will just become 8. There. By subtracting 7 from both sides, we've changed the original equation, x plus 7 equals 15, into the new and much simpler equation, x equals 8, which tells us that the unknown number is 8, and we've solved the equation. And to check our answer, to make sure we got it right, we can see what would happen if we replace the unknown value in our original equation with the number 8. Instead of x plus 7 equals 15, we'd write 8 plus 7 equals 15. And if that's true, then we know we got the right answer. Pretty cool, huh? Let's try another one. 40 equals 25 plus x. This time, the unknown value is on the right-hand side of the equation. Does that make it harder? Nope. We use the exact same strategy. We want to get x by itself, but this time x is being added to 25. But thanks to the commutative property, that's the same as 25 being added to x. So to isolate x, we should subtract 25 from that side of the equation. But then we also need to subtract 25 from the other side to keep things in balance. On the right side, x plus 25 minus 25 is just x. The minus 25 cancels out the positive 25 that was there. And on the other side, we have 40 minus 25, which would leave 15. So the equation has become 15 equals x, which is the same as x equals 15. Again, we've solved the equation.
I'm just going to highlight a few questions on page 526 to 529. So we're looking at solving equations using either inspection or models. So inspection simply means that when you see it, you just know the answer, and using models is using the tiles that we've been looking at the last few days. So if I look at this question, 3x equals negative 12, I just know that 3 times negative 4 is negative 12. That's called inspection, so x would be negative 4. If I go and I look at the models over here, I look and I see that across from each of the x's, I've got 4 negatives. So my answer is going to be negative 4. Same answer in both places. Moving on to the next page. So I look here and I see r divided by negative 2 equals negative 7. So I'm trying to figure out what number divided by negative 2 is negative 7. Well, that's going to be 14. 14 divided by negative 2 is negative 7. So in this case, it says r. Here it says x. It should be r equals 14. Now, if we go over here to the check or verify, as you'll sometimes hear it called, this is very important, and it can be a little bit confusing at first. So if I look here, I've got r over negative 2. What they've done in the second step is they've simply given you a box so that you can go back and you can take r, which you said was 14. So 14 divided by negative 2 is negative 7. Left side, right side are exactly the same. So you can do the same thing over here. What number divided by 3 equals negative 8? Well, I know that negative 24 divided by 3 is negative 8. So my answer would be t equals negative 24. And if I go and I put that in here, negative 24 divided by 3, I will get negative 8. If I move over here, if I were using models, I would draw 4 of the long x's and I would shade them in. And then I would draw 8 empty squares or white squares. And I would see that there are 2 squares for each one of the x's, which means that x is negative 2. And if I plug that in over here, 4 times negative 2 is negative 8. I would be correct. My answer would be negative 2. On the other side, I've got something divided by 2 is 5. Well, that's easy enough. I know it's 10. And if I go down here and check 10 divided by 2, sure enough, It's 5.
Well, guess what? Multiplication and division are also inverse operations, so we can use them to undo each other too. If an unknown is being multiplied by a number, to undo that, we need to divide both sides by that number. But if an unknown is being divided by a number, to undo that, we need to multiply both sides by that number. Now, don't worry if that sounds a little confusing right now. It'll make a lot more sense after you've seen a few examples. Let's start with this one. 3x equals 15. Excuse me, I think you forgot something. I mean, didn't you say that these equations were going to have multiplication or division in them? But I don't see any arithmetic operator at all in this equation. Actually, I think you forgot something that we learned in the video, What is Algebra? You did watch that, right? Oh, sure, of course. But I just remembered I have something I gotta do. I'll be right back. Well, I'm sure you remember that multiplication is the default operation in algebra. So when you see a number and a symbol right next to each other like this, with no operation between them, it means they're being multiplied. So 3x is the same as 3 times x. Oh, and just a side note, since in multiplication, the order of the numbers doesn't matter, you could switch the order and write x3, but it's customary to always list the known number first and the unknown number second. All right, but we need to solve this equation, right? That means we need to get the unknown, x, all by itself on one side of the equal sign. Right now, the x is not by itself because it's being multiplied by 3. So to undo that operation, we need to divide that side by 3. In algebra, we almost always write division in fraction form. So to divide this side by 3, we just write a fraction line under it and we put a 3 below the line. There. This means 3 times x divided by 3. But don't forget our rule for rearranging equations. We have to do the exact same thing to the other side to keep the equation balanced. That's better. Now both sides are being divided by 3. The next step is to simplify. The 3 on the top and the 3 on the bottom on this side cancel, because 3 divided by 3 would just be 1. This is just like canceling common factors when you're simplifying a fraction. That leaves us with just x on this side. And on the other side, we have 15 divided by 3, which simplifies to 5. There, we've solved our equation by changing it into the simplified form, x equals 5. Let's try another one just like that. 12x equals 96. In this problem, the unknown is being multiplied by 12. So to get the x all by itself, we're going to need to divide both sides of the equation by 12. On the first side, the 12 on top and the 12 on bottom cancel out, leaving just x on that side. And on the other side, we need to divide 96 by 12. You might be able to do that by memory, but if not, you can use a calculator to divide. 96 divided by 12 is 8. So in this problem, x equals 8. That's pretty easy, isn't it? Are you ready to try a division problem now? Here we have x divided by 2 equals 3. Now, when you see division written like this, from left to right with the traditional division symbol, I want you to rewrite it using the fraction form for division. And that's because it's much easier to cancel common factors and simplify your equation when you use the fraction form. Now that we have it rewritten, let's solve it. We can see that the unknown is not by itself because it's being divided by 2. How can we get rid of or undo that division? Yep, we can undo division with multiplication. So we need to multiply both sides of the equation by 2. Instead of writing the multiplication sign, I'm using the parentheses notation that we learned about in the video called What is Algebra? Remember, the multiplication is just implied. Now to simplify. On the first side, the 2 on top cancels out the 2 on the bottom, since 2 divided by 2 is just 1. And I know what some of you are thinking. How is there a 2 on top? The 2 looks like it's really in the middle, kind of like how a mixed number looks. That's true, but don't confuse this with a mixed number. Mixed numbers involve addition, but the parentheses let you know that the 2 and the x over 2 are being multiplied, since multiplication is the default operation. Okay, so it's not a mixed number, but how is the 2 on top? Well, do you remember how you can turn any number into a fraction just by making 1 the bottom number? That means that 2 is the same as 2 over 1. Now you can see that the 2 really is on top. It's just that we don't usually show the 1 on the bottom. All right then, so the 2's cancel, leaving the x all by itself on this side. And on the other side, we have 3 times 2, which is just 6. So in this problem, x equals 6. That's not too hard either. Let's try another one. X over 10 equals 15. In this problem, since the x is being divided by 10, to get it by itself, we're going to need to multiply both sides of the equation by 10. On the first side, the 10's cancel, leaving x all by itself. And on the other side, we have 15 times 10, which is 150. So our answer is x equals 150. Great! That's how you solve simple equations where an unknown is being multiplied by a number or divided by a number.
Now on the next page, we start using something called opposite operations. So this is different. This is not inspection anymore. And opposite operations are incredibly important as we go forward in algebra. Of course, they had to start you off with a little bit of a difficult one because we've got a negative here. So I've got -5 times b equals -45. Well, the opposite of times is divided by. So in order to get rid of this -5 here, I have to divide by -5. Whatever I do here, I have to do on the other side. Put -5. So -45 divided by -5 is 9. I move on to the check. -5 times 9 does equal -45. I've got the correct answer. Same idea on over here. I'll let you do that one on your own. Last example, the opposite. I've got d divided by -5 equals 3. Well, what's the opposite of division? That would be multiplication. So all I have to do is multiply by -5 to get d by itself. If I multiply on the left, I multiply on the right. 3 times -5 would be -15. -15 divided by -5 is 3. I've got it right. If you felt like I was going a little too fast for you, don't worry about it. Go back and watch it again, and then you can do your assignment, which is, I've lost it here, these 6 questions